We have a pentagon A, B, C, D, E inscribed in a circle, and we need to find its area. The circle has center O and radius 1. Notice that AOD forms a diameter. We're told that sides AE and DE have equal length. We also know that side BC is parallel to the diameter AD. And the length of side BC is exactly 1 unit. Here's the key insight. We can split this pentagon into two simpler shapes. The first shape is triangle ADE at the top. The second shape is trapezoid ABCD at the bottom. Let's analyze triangle ADE first. The base AD is the diameter. Since radius is 1, diameter is 2. Since angle AED is inscribed in a semicircle, it must be a right angle. The height from E to base AD is the radius OE, which is 1. Now let's examine trapezoid ABCD. We know the parallel sides. AD has length 2, BC has length 1. To find the trapezoid area, we need the height between these parallel sides. Let's drop a perpendicular from center O to chord BC, meeting at point M. Now consider the right triangle OMC. We have all the pieces. Time to calculate. The pentagon area equals triangle area plus trapezoid area. The area of any triangle equals 1/2 times base times height. This comes from the fact that a triangle is half of a parallelogram. Applying this formula to triangle ADE. Base is 2, height is 1, so triangle area is 1. For any trapezoid, the area equals the average of the parallel sides times the height. This formula works because a trapezoid can be seen as the average of two rectangles. Now we apply this formula to trapezoid ABCD. The Pythagorean theorem states that in any right triangle, the square of the hypotenuse equals the sum of squares of the other two sides. Applying this theorem to our right triangle, OMC. Radius OC is 1. Distance MC is 1/2. Height is h. Solving gives h squared equals 3/4. So h equals square root of 3 over 2. Trapezoid area is 3 over 2 times square root of 3 over 2 equals 3 square root of 3 over 4. Adding triangle and trapezoid areas gives 1 plus 3 square root of 3 over 4. This is our final answer, the area of pentagon ABCDE inscribed in the unit circle. Notice how we broke down a complex pentagon into simpler geometric shapes that we could calculate directly. Thanks for watching. If this helped you understand geometric problem solving, please like and subscribe for more math content.